My name is Richard Henry, and you're listening to the COVID-19 Challenge podcast. We know that ACE2 is key to understanding this virus, is key to how the virus works, and it's key to what makes us sick. But knowing that hasn't yet translated into the medical system providing a well-oiled defense plan against this. And that's surprising to me, very saddening, and also a little bit scary. I'm not the only one who's come into the understanding that this is an ACE2 mediated disease, and we should be focusing all our attention on ACE2. I'm not the only one, but you probably won't hear much about it on the mainstream media. In fact, probably, if any of you listen to this, you probably never heard of ACE2 and will wonder why you haven't. So, what kind of human is expressing on ACE2 and is relying on ACE2, right? So we all have the similar genes. So then it's what genes are you using? So what phenotype human is not using ACE2? And just to briefly, if you're young, thin, fit, and female, and probably also if you're European or so-called white, then you have very low dependence on your renin-angiotensin system to raise your blood pressure. You have a very nice cardiac output, lots of perfusion in those wild-type, healthy, fat-free muscles, and so you very seldom, you drink enough fluid, you eat well, so you have very little need for this defensive renin-angiotensin system to come in and try and save you. We can't all be European, young, and female, but we can also look at some of the other things that contribute, because there are the at-risk genotypes who still don't die. So why would some old, fat African-American men die and some old African-American men not die? And so what if we could reduce the risk in all of us, so that not only would very, very few of us die, but also those of us who get sick may not get quite as sick. The classic phenotype for renin-angiotensin stress is recognized by a disease called metabolic syndrome. Very, very common disease for those of you who are in medicine. And basically, it's a syndrome is just a collection of things, collection of state of affairs that make up a disease. But it's not really a disease because we don't have a process for it yet, so it's called a syndrome. And so syndrome is basically made up of, metabolic syndrome is made up of being overweight, high blood pressure, cardiovascular disease, and diabetes. So we start off with being overweight, and then that increased fat needs to be perfused. So it increases aldosterone production, which then stresses the cardiovascular system endothelium, which then becomes diseased. And then also those fat cells are stuffed full, and they become resistant. They can't take any more food. They can't take any more glucose. They can't store any more fat. And so the membrane receptors that would normally let glucose in get dialed down, and they become resistant to insulin. They do not want any more glucose, and they say, go away. And so glucose is left sloshing around in your bloodstream, and the kidneys will try and get rid of it. So you end up with glucose in your urine. So it's not actually the glucose that makes you sick, but it's the effect of high glucose, which we'll talk about one day. So the key to all of this is obesity and perfusion. And so we have a system that's designed to keep fat alive within our body and to keep it perfused. If we're not going to lose weight, what can we do in the meantime? Well, what if we could decrease the renin-angiotensin system, dial it down so that it wasn't quite as strong, and find a blood pressure that was livable, but without taking off some of the stress? So what if we could find a drug that worked the same as ACE2, that would come in and help ACE2? So the opposite of ACE2 is ACE1, and ACE1 produces a signaling protein called angiotensin 2, which binds to an angiotensin receptor, which then causes that cell to raise the blood pressure. So if you want to, you can either block ACE, the enzyme itself, and we have ACE inhibitors, and we also have angiotensin 2 receptor blockers. And so these drugs have actually become the mainstay of treatment in metabolic syndrome, and they work relatively well compared to the other drugs that work on the sympathetic nervous system that were originally invented in, say, the 50s, 60s, 70s. So we know that angiotensin receptor blockers do work fairly well in metabolic syndrome. They certainly don't stop strokes and heart attacks, otherwise we wouldn't have any in the world, and those units in the hospital would be empty. But when you look at some of the early results done with people who were on angiotensin receptor blockers who developed COVID, compared to similar humans with the same phenotypic features who weren't on angiotensin receptor blockers, those on the blockers had 60% better survival rate than those who weren't. And so these drugs really do help quite significantly. Unfortunately, what's been written in the literature is to patients who are on them should stay on them. But we haven't made the transfer yet to say maybe everyone should be put on them at the beginning of the disease in order to try and get some of those benefits. So we're at the stage of don't take someone off them, leave them on it, but we haven't crossed over yet. Equally, aldosterone receptor blockers, which are working further downstream. The one that everyone in medicine knows is called spironolactone. So that blocks the aldosterone effect, which is in fact causing those target cells to make the apparatus for stress. So spironolactone works really well in treating metabolic syndrome, but unfortunately is only used very late. So when people are in sort of late end-stage metabolic syndrome and are within a year or 2 or 3 or 4 of dying, then spironolactone often gets added. For some reason, it gets added late. So spironolactone is blocking aldosterone, which is trying to retain sodium in water. It's blocking that effect, so it gets you to release the extra sodium water. Spironolactone is thought of as being a diuretic when it really is not a diuretic. It's just an anti-diuretic. So it has a diuretic effect by blocking aldosterone. So let's back up a bit. While we're in this crisis, there are potentially a whole slew of different drugs that work on the renin-angiotensin system that could well be used right away, starting tomorrow, and you used quite safely by physicians who know them really well to try and block this aldosterone-mediated cytokine crisis, cytokine storm. But in fact, if we back up even further, the trick is to be that skinny, fit, muscular, young person. And so who's not making very much aldosterone at all. So to do that, the key, one changeable thing is to decrease weight, particularly visceral fat, and to convert, get the fat in your muscles, where your muscles are, to get the fat out of that. So you want to go from being a overweight or obese person with a big fat tummy, to getting that fat to actually be metabolized, used up, and those cells to shrink. We also want to increase exercise and movement on a daily, hourly basis. So every time you jump up and move, versus use the clicker for the TV, when you jump up and move, you increase muscle activity, increase cardiac output, increase blood flow, increase pressure for a bit, and that perfuses everything using your sympathetic nervous system and not your aldosterone system. And so being a wild type human and moving all the time is going to induce use of the much safer blood pressure control mechanism. And then of course you want lean muscle that is well capillarized or well perfused. And to do that, you need to do exercise, right? You need both muscle bulk, but most of all muscle flow. So that's when you want to be fit, where you can actually because blood vessels will infiltrate muscle as much as muscle needs it, and so nature's continually slowing down things. So if you don't use the muscle, if you don't use it to exercise much, you'll actually get fewer and fewer blood vessels running through that muscle, and in fact it'll become a storage site for fat, which then is poorly perfused in itself. And so that's going to try and increase, rather than getting blood vessels to increase through the fat, it just increases pressure. To a large extent, much more so than, say, lean muscle does. The other important thing is to make sure you do get enough sodium in your diet and water. And so you can play with that and become very scientific and treat yourself as a lab rat, or you can just eat natural food and drink water. As those foods have evolved with us and we've evolved with them, so just eating fruits and vegetables and drinking normal, fresh, healthy water. In the event of being sick, one of the old tried and tested grandma foods is chicken soup, right? Which is going to be high in salt to make it taste nice, and a lot of other very, very, very effective amino acids and fluid. And so chicken soup is actually really quite scientific. So we've talked about blood pressure medications, the AR blockers. Their drug name ends in sartan, so they're called the sartans. We've got the spironolactone and eplerenone, which will block aldosterone receptors directly, which are unfortunately saved for end-stage disease. So very few people are on them, and they are very sick. But if you turn that around, the fact that really, really sick people can tolerate spironolactone means that it's a pretty safe drug. So giving it to somebody who is in a sick state, is quite ill, with physicians who are quite used to the drug and the effects of, and quite used to understanding the effects of the drug, wouldn't be too far of a fetched thing to happen. And I'm very distressed that we're not using aldosterone receptor blockers or MR blockers, spironolactone in this syndrome, in this disease. If I had high blood pressure, other than exercising, losing weight, trying to do it naturally, if I had to pick a pharmaceutical, I would use eplerenone, which is the same as spironolactone. It's an aldosterone blocker, but it doesn't block the testosterone effect, so that I wouldn't become feminized. It maintains its stealth during reproduction and it escapes unharmed. The fact that humans are harmed is not really part of the viral survival mechanism. And so what we're finding is that phenotypically altered humans, and I call them domesticated humans, those of us who have a sedentary lifestyle, who eat 3 or 4 times a day, our room temperature never changes, and on and on and on. We're overweight, unfit, overfed, that those phenotypic humans, which we call basically metabolic syndrome, have had to increase their ACE2 expression in order to protect themselves and try and prolong their life. And the virus then can use that ACE2 to enter the cell, no big deal. But it's when the ACE2 is now depleted and that domesticated human is left acutely with an inflammatory reaction to the virus on top of the inflammatory reaction to acute ACE2 depletion, that this summates into an illness that is catastrophic. I don't need to describe the illness because we're all a year into this pandemic, and all of us know or have heard of somebody who've read or watched on TV what this illness is, but in fact it's just endothelial-mediated cytokine storm disease, which both causes endothelial dysfunction and leakiness, as well as endothelial hyperfunction and increased coagulability, and therefore clots and strokes and bleeding. So I don't think this virus is going to go away, ever. I think it's going to be impossible to eradicate this virus now that's here. It's become part of life on Earth, and humans are going to have to adapt to it. But really what you want to do is adapt yourself so that your risk of dying and getting sick is really quite minimal. So you want to go back to being a wild-type human. So that means we want to be thin, fit, and active, and out living in nature. So it's possible that this virus has come along to challenge our city-based, domesticated-based life, where we sit around in climate-controlled environments, hardly ever move, drive to work, elevator up to the building and back and forwards, and are never short of food, never hungry, and don't really exercise. So on a big picture scale, we know that viruses come along and challenge the herd to be healthy, and will knock off the weak. And it's possible that the domesticated humans, in terms of nature, are considered weak and are now susceptible to this virus. So are we going to try and maintain our weakness and survive this virus in our weakened state, or are we going to have to just come to terms that nature is actually the boss, and that for us to survive, we're going to have to look at who survives and try and be like them. We can do this with scientific knowledge, but really it doesn't take much. Grandma knew that chicken soup made you feel better, and you look around and it's very quick. I've asked my colleagues who work in ICU what kind of humans are lying in those beds, and the answer comes back every time. It's the older men, and they're all overweight. Humans have sort of migrated in from a wild type life into a city life, and we're making some big mistakes, and maybe this virus has come to show us those mistakes. And it's not done intentionally, it just is. So a lot of evolution and biology just is. And if those biological systems that are successful survive and those that aren't die, it just is what it is.